Inspired by professional learning sessions with Galileo Educational Network and an investigation into the processes used by engineers, these teaching partners designed an authentic, discipline-based task framed by an understanding of the Teaching Effectiveness Framework. Keeping in mind the 5 key principles of the Teaching Effectiveness Framework, these teachers worked to purposefully design an engaging task, embed formative assessment to improve student learning and inform their next teaching steps, as well as foster meaningful relationships around the work, all while effectively collaborating themselves. The processes and ways of knowing inherent in the engineering field helped to guide these teachers as they intentionally designed the learning experiences for students. Teachers thoughtfully considered how to engage young children in a junior version of the same processes that engineers use to design and build new structures. Through problem identification, research, blueprint creation, building, testing, troubleshooting, and tweaking, students were tasked with building their own sleds that would travel effectively down a slope.
In order to succeed at their task of designing, building, and testing an efficient sled, students were required to understand, apply, and consider how key scientific understandings such as gravity, friction, pressure, and air resistance will impact their designs.
A local engineer was invited to work alongside students and help inform their designs prior to building. He engaged learners with real-world case studies, issues, questions, and ideas as to how engineering processes can help you go fast.
Students collaboratively engineered actual sleds that would be tested at a local ski hill. Using structural design processes, students sketched out their unique ideas and drafted detailed blueprints. Under the careful direction and instruction of student teams, parents assisted the students building prototypes based on their blueprints.
In another real-world application, production costs were estimated and calculated. Pricing and profit margins were established based on students' individual calculations. One group decided that, in the long run, it would be more profitable to rent their craft than to sell it.
In order to formatively document student learning throughout the process, each child recorded and kept track of their designs, production challenges and successes, and testing in their engineering logbooks. Feedback loops, both self and peer, were carefully woven into the learning process to help inform students and teachers' next steps. This task had an intentional focus on effective collaboration and teamwork. While some students found this challenging, several reported that they learned about how to work as an effective team to tackle a complex problem.
Just as engineers experience a sense of accomplishment associated with solving a design challenge, our students clearly demonstrated the same thrill and excitement of conquering their challenge. Learning truly came to life the moment students pulled on their helmets, climbed into their prototypes, pointed it down the mountain slope, and hung on for the ride of their life.
The testing took place in tubing lanes, which were pre-designed and equipped for this type of activity. Using a radar gun provided by a local police officer, sleds were clocked traveling between 20 and 30 kilometers per hour. The community, including our school, parents, the ski hill, and school division, were all anxious to learn how our students' sleds performed. Therefore, the testing day was documented and made visible by leveraging social media, including Twitter and the school's Facebook page.
Clearly, the effective teaching practices documented here engaged learners not only intellectually, but vertically as well.